Hi, this is James and Alex, and this is our Matrix movie. First, let me introduce some vocabularies. Matrix is any arrangement of variables or constants in horizontal and vertical columns. Now we will introduce some basic simple operations. First, addition. To add two matrices with the same dimension, add the corresponding elements. Our next stop is multiplication. Two matrices A and B can only be multiplied if and only if the number of columns in A is equal to the number of rows in B. When you multiply these two matrices of the products A and B, the resulting matrix AB is an M times T matrix. Here is an example of this concept. In this problem, the inner dimensions come out to be equal, so the product is defined. Its dimensions come out to be 1 by 2. Before we move into scalar multiplication, let us explain what scalar is. Scalar is a constant that a matrix can multiply by. In scalar multiplication, the scalar, which is k in this case, is multiplied to each component of the matrix provided. Moving forward, Cramer's rule is also a crucial part of the matrices. First, you must know that there is a determinant in every square matrix. Now, a 2 by 2 matrix has a second order determinant. Quite similarly, a 3 by 3 matrix has a third order determinant. Now, here is an example of the second order determinant. To find the determinant of a matrix, you have to multiply the diagonals of a certain matrix. In this case, it will be AD and BC. Then you have to subtract them. For example, we have 4, 5, -3, -6. You multiply 4 and 6, then you multiply 5 and -3. Then you subtract from one another, which comes out to be 39. Moving on to third order determinants, it is divided into two steps. Step 1, you move the first two columns of the matrix to the right. Then, as shown below in step 2, you multiply the crosses of the diagonals of each line to the right. Then you repeat the step 1 and step 2, but you do it in a different direction. Then there are identity matrices. The 2 by 2 identity matrices go by 1, 0, 0, and 1. In a similar pattern, the 3 by 3 matrices go as 1, 0, 0, 0, 1, 0, 0, 0, 1. To find the inverse of an A matrix, which is defined as A, B, C, and D, you have to follow the steps of an equation. First, find the determinant of the matrix, which is AD minus BC. Then you have to divide the determinant over 1, because it is an inverse, which is a reciprocal of product A. Then, with the A, B, C, D factors inside matrix A, you have to also make that a reciprocal. So the result comes out as D, -B, -C, and A. Then you plug in those numbers provided, then you will be resulted as an inverse of the matrix.